Oh, wow. A lot more talks. Well, just sprinted over here, so still catching my breath. I don't know how Titan and Gattaca got this venue, but fantastic views and close to everything else. But yeah, I appreciate everyone coming in to listen to this. Feel very passionately about this. Hopefully you see some of my excitement. My name is Drew Van Werff, and fell in love with Ethereum 2016, and never really looked back. Had a few roles in TradFi where I focused on crypto, so couldn't be as public, but behind the scenes have done a lot around technical infrastructure that's Ethereum aligned. And recently left to work on this thing called Commit Boost, which I'll talk about. But really I'll give some history behind how I see the future of block building looking. And maybe the block builders in the room may not be as happy as the proposers, but I think that's how Ethereum should be. So that's a little intro with myself. This is the agendas. Just to kind of talk about this concept of proposer commitments, which I'll lean into. Some other much smarter, better thinkers than me have talked about this for some time. Today's structure and with tomorrow's commitments, kind of how I see this adapting. Hopefully, I'm kind of bad with memes. Came up with one this morning that I wish I didn't have time to switch the slide out, but I'll highlight that. And then I've got a shill commit boost, so I'll end with a potential solution that I'm trying to get the community to buy into, but certainly it could not be the end game here. So yeah, so some of you have maybe seen the slide. I did switch up the ordering of the quotes, but my thesis is around how do we get block construction to a place where it's the proposers specifying or dictating the template of how the block can be constructed versus today, 95% of the market says, hey, someone build my block, just make sure it's the most profitable. And there are some constraints that get done off chain around that, which I'll go into a bit, but that's a majority of how blocks are built today in Ethereum. And it really removes some of the power from the proposer. And so here's some quotes. Best one, I think, recently from Vitalik, sort of thinking about, can we make inclusion lists 80% of the block? And then some actors build around that. That's kind of one mental model. And actually, Barnaby, I think, has the best mental model, how to think about this, but proposers give templates of how their block can be constructed. And I'll dive into a bit of these. And the last is by Julian, and I highlight this because if we have in-protocol inclusion lists, some of the challenges are people are going to use the inclusion list, not for its intended use. So pre-comps is a hot topic. People will probably fill the inclusion list with things like commitments for pre-comps instead of what they're intended to be, which is reducing the risk of censorship or increasing censorship resistance in Ethereum. And my thesis around this is if we can give proposers the ability to specify a template, some may actually censor, so they won't use the inclusion list, but there are some people who are proposing in Ethereum that will absolutely specify that, and they'll make conditions around how the inclusion list can be used. So it can't be filled with these things, or you have other tools to fill other parts of the block with those things you would have put in the inclusion list. So instead of pre-comps going inclusion lists, pre-comps are part of the other part of the block. So validators today, they say, hey, someone build me a block. And that's it. It's kind of funny because we talk about proposers as having a monopoly, but I guess I question whether they have the monopoly if they say, build me a block. It's kind of like having a monopoly without any specification of how the monopoly runs. So just like an open monopoly board, do whatever you want. There's no rules to this game. And so I think, unfortunately, right now, proposers maybe aren't they don't actually have a monopoly. It's in fact, they're giving it away to the PBS pipeline and actors downstream. And I also want to highlight when I say builders today, you could bucket in relays, really anyone downstream that's able to add features around the block that the proposer may not have wanted when they had outsourced it. So block builders today, this is a live look at Kubi. I don't know. To me, the actors downstream actually have a majority, if not all, the power. And I guess SCP and or Beaver and rsync, whatever. I'll bucket these guys onto Ace Ventura here, happy and just walking around. I don't know, Brussels. Don't know how you could be too happy in Brussels, but here we are. But how I think about this, and I touch on this is just more of a mental model, is how I think about validators tomorrow is they still say, fill my block. there's likely still going to be delegation. In no way am I saying that we should push all the sophistication on the proposers. There's still going to be a pipeline that they can say, hey, I'm going to delegate this out to. But instead of just having the square box, which was on the first slide of validators today, they've put other shapes in there, which you can think of as conditions of if you're going to construct my block, these things must be included. And so I used examples here of inclusion list, PBS, which, MEV boost, we know that today, and top of block auctions. And so maybe this validator says, those are the services I want to make sure are supported as part of my block. And so when it's their time to propose, they essentially tell the supply chain, these are the conditions you must meet. And this is my best vision of the proposers. I don't know if everyone culturally this translates. This is Judge Judy, making the conditions. These are the proposers of tomorrow. Now, what does this mean for builders or downstream people? This was the best example of someone sad. But I think actually a better picture of this is Mr. Clean. I don't know if you guys know the Mr. Clean, bald head, he's always smiling. And how I think about downstream, if we're able to use these conditions and constraints when blocks are proposed or the proposers make these for downstream users, the people downstream actually become polishers. They become these people that are just shining the block. They're given so much of a template that they really can't do much other than, maybe optimizing within those constraints, but it's really about they're just kind of shining the block. And they become, like Vitalik said, 80% of the block is actually constructed by the proposer, or a template is constructed by the proposer. And it's really like that last 20% is just getting shine. And the reason I see this is more Ethereum aligned or potentially a path forward for protecting Ethereum ethos is instead of the 3 relays, 3 builders, whatever number it is, you now have 1 million validators. And I'll get into this. I do understand that there's implications for this, but when I talk about the PBS pipeline of today, I think you'll find that there are some actors already doing this, and we're not enabling anything new. We're just more formalizing it, which, yeah, you could argue is acceleration, but again, I think this is happening either way, and we just need to address it. So this is what happens today. Most people are probably familiar with this. Not going to spend too much time on it, but a proposer via the MEV boost software subscribes to a relay, say, hey, build my block when it's time to propose. The builder builds the most profitable block. They accept the highest bid. But what actually happens for some proposers, not all, there are actual constraints that when the proposer registers to a relay, they actually prescribe those. It's just all off chain. And a great example of this is actually censorship. So certain relays will have multiple services where some blocks are censored, some are not, and proposers will subscribe to certain one of those services. And there's a whole host of other things that happens behind the scenes. I don't know all the details here, but there's other constraints actual proposers put on relays or builders. It's just in a very informal way. And so what I'm arguing is that while MEV boost is the most prevalent commitment people make, there's actually other commitments people are already making. And proposers are very much open to this idea. And formalizing that, I think, is incredibly important. And so when I mean formalize it, instead of having those red arrows, actually what a proposer does is when it's time to propose, it says, hey, build my block, but there's also these constraints. And then the builder builds the block according to those constraints, or even other actors can build part of that. Now I'll get into the commitment types that proposers could have. These are the most, I think, explored examples or talked about. Block space futures have been discussed for a long time, good or bad, not really sure, but here they are. Partial block auctions is another. PBS is a form of proposer commitment. We obviously are familiar with that. Pre-confs, which is the hot topic, contentious topic of today, I guess, an inclusion list. But if we create a software that allows proposers to make these conditions and constraints, there's actually a whole host of other things that maybe people haven't thought about. My block must be ordered by priority fee. You have that today with local block building. What you're missing is the private mempool, which now is 30% of blocks. So if you were allowed as a proposer to say this and there was a delegation still of block proposing, but the condition was you still must order by priority fee, it's kind of an interesting thought process. All transactions must be encrypted. Again, I haven't explored all these ideas in the technical details, but these are just things I've heard people talk about or thought about myself. Oracle updates must be at the top of the block. It's a service that a proposer could sell. Block has no sandwiches. Man, that wouldn't have MEV. I don't know. It would be a lot less contentious, but people that are aligned with that could specify that, for instance. The block must include XYZ standard. So there's a lot of discussion around intents. And so there may be people who are interested in having transactions only align with a certain intent standard. Proposers, if they subscribe to that, could have that as a part of their block or a good chunk of their block. All the blobs must be filled. I know the builders don't like this, but this could be, if you're aligned with Ethereum and you want to support, the direction we're headed, instead of builders playing time games with blobs, you actually don't allow them to do that. And the blob space must be filled. Align my block with the values of Ethereum, and this has a lot to do with inclusion lists and these other tools. And yeah, last is latency game type extensions, where maybe we just embrace latency to some extent, and we say proposers can specify how much risk they're willing to underwrite for missing a slot. And then the list goes on. So this raises the question, proposers wield the power, you say. This is the oracle, I think, of society. Just kidding, but trust them, we must. And my perspective is, it's better to trust the million validators that are supporting Ethereum versus the actors downstream, allow them to make conditions that others must fulfill. Now, I'll get into quickly, I don't know how much time I have, hopefully 5 minutes, but I see this as a massive unlock for Ethereum. It switches the power dynamics between what we have today, which is, proposers have a monopoly, but they have very little into how their block is constructed, to like they have all the input into how their block is constructed if they choose. Today, though, the problem is there's other people who see this, and thesis being proposers are going to make more commitments than they are today. A lot of the ways people are implementing this is with different sidecars. So they're going out to proposers and saying, hey, run my sidecar. This creates a lot of fragmentation. Proposers have to run potentially 5 to 10 sidecars, which is not good for a lot of reasons. OPSEC, security, pretty much excludes home stakers to some extent. They probably can't support that many sidecars. Even for sophisticated actors, they don't want this. This also increases developer complexity for Ethereum core devs. So during hard forks today, we already have challenges with the sidecar that's out there, which is MEV-Boost. And again, nothing harking on the MEV-Boost, but the team that supports these things, it's just a challenge to coordinate around that. If we had 10 of these though, it's even worse. And then just transparency. So when there are bugs, if we have 5 to 10 sidecars, it's going to be really hard to coordinate around making the changes required. And so the idea is that at least I've been pushing, come up with, and started a couple months back, is this concept of commit boost, which I'm not going to go through all these details, but the mission is it's a public source, open code project. There's no VC backing. It's a not-for-profit. And commit boost is a validator platform to safely make commitments. So it attempts to unify standards for the last mile of communication between the proposer commitment protocol and the proposer. And so what ends up happening is you run commit boost as one sidecar. Instead of running all the other sidecars for every commitment, those teams agree to build modules on top of commit boost, and you as a proposer can opt into these things. And so how it would work probably day one is, instead of running MEV-Boost the sidecar, you actually run commit boost the sidecar, and you opt into the MEV-Boost module. And so you're still enabling plain vanilla PBS, but then in addition to that, as more proposer commitments come to market, such as pre-comps, you can opt into those modules. And then let's say inclusion lists get built as a module, which we're working on now with some teams. You as a home staker could actually, or someone that supported Ethereum aligned ethos, you can opt into that as well. And the idea is to create a neutral platform that is out of protocol, but it's the best we got today until we can make in-protocol changes. And it's designed in a way, and Vitalik actually talked about this the other day, is there are a lot of things happening outside the protocol today. You can be an anarchist, put your head down, and just say, this is my protocol, I'm willing to protect it, do whatever you want outside of it. Or on the other side of the scale, you can say, we're going to include all this stuff in protocol. We're going to try to ship it inside of Ethereum. And the middle ground is, there's a lot happening outside of Ethereum, more than ever has. And we may have to rely on out-of-protocol solutions to reduce some risks that are developing around that. So let's ensure, if we're relying on those out-of-protocol solutions, they're designed in a way that are neutral, are an actual public good, aren't getting monetized. And so that's what the needle we're trying to thread. I don't know if I have time for the architecture, but if anyone wants to discuss this afterwards, some of the teams that are thinking through this, I think Daniel from LimeChain is here, and Kubi has helped out quite a bit on this, and there's been some others involved, but this is kind of the high-level framework. Like I said, you run commit boost, which is one sidecar, and these modules become the commitments you can make as a proposer. And a lot of what commit boost actually focuses on is more on safety for the proposer and how it standardized how it provides the commitment to the outside world. So it's not opinionated once it provides the commitment on how that's enforced, how it's handled, how often it's requested. It's really an unopinionated open platform, so anyone can design on top of this, and there shouldn't be limitations. But it just provides a lot of key things for safety for proposers. Happy to go through details on that, but in the essence of time, we'll skip over that. So who's been contributing to Commit Boost so far? This is just a slide of, I don't know, I think there's 30 or so people on this, or teams. It's actually much bigger than this. We just couldn't include everyone for either corporate reasons or we just didn't have enough time. But if you want to be part of this, here's how you can help. This truly is an open source public good, raising grant fundings, but there's a whole host of ways you could get plugged in behind the scenes if you have some of these skills and want to contribute to something that could benefit Ethereum. But yeah, with that, here's the QR code to the repo, a link. We're basically on MVP status is what I'll say. It's been a bit of a sprint. We're running in a testnet called Helder, which is a persistent testnet for people building pre-comps, base sequencing, as well as proposer commitments. And then we're also testing on Haleski with, 10 plus validator teams. And in that implementation is just MevBoost plain vanilla on top of Commit Boost to make sure all the pipes are working cleanly. Yeah. Awesome. Well, I appreciate everyone having me. I guess maybe we have a couple minutes for questions, if there are any.
Does this increase reliance on relays at all? And is that a bad thing? Because like last I checked, I've been kind of out of the loop with the PBS stuff, but relays were like temporary and we were trying to get rid of them.
I think so Commit Boost is designed for delegation. There are teams which are working on non-delegated pre-comps, for example, and so it requires the proposer to do the sophistication. This doesn't really help tackle that. It's more for delegation. Now, the thing that Commit Boost does do is it opens up the transaction flow. So today, pretty much you have to rely on the PBS transaction flow, but what could happen is people could build modules where the commitments are actually constructed by someone other than in the PBS supply chain today. And I use this example. I don't know specifically like how Swab works and everything, but you can imagine a condition or constraint that a proposer wants to impose for its block construction that actually has to rely on the Swab network instead of the relaying builders of today. Or you could have a commitment that's directly connected to, say, searchers. And there's someone that has to aggregate this all together. That's why I say I think builders of the future are more like shiners, is they're aggregating all these different peoples and their input. But yeah, I actually think it actually could help decentralize away from relays, but it still is going to rely on delegation. So there likely will be some form of centralization around these commitments.
Cool, thanks.
Close.
I just have a question. So your argument is that there is a proliferation of sidecars, and that is creating a lot of complexity, and that's the reason for Commit Boost. But why, how come that this doesn't just shift the complexity into the proliferation of Commit Boost modules? If there are 100 modules to maintain anyway, and they can be in conflict with each other, it's basically the same problem, just one step down.
It is, yeah. It's abstracting the problem further away from the client, which I think is what we want to end up having. So when we have hard forks, proposers have opted into modules. From an Ethereum perspective, they don't want to have to rely on, they're unopinionated on all these modules because they're like one step removed from the client. And similar to when we do MevBoost, if a relay is not running properly, yeah, it sucks, but it's not really, like the Ethereum sort of issue. Not that MevBoost is Ethereum issue too, but that's how it kind of plays out. Is MevBoost is very involved in the client's discussions. It's involved in the test network. So like you're 100% right. We're trying to abstract all of that non-standardization away from just the last mile of standardization. So it's a fair criticism, but that is a feature, not a bug.
Okay, thanks.
Yeah, and Commit Boost doesn't have opinions on the modules either. We're not running you could build whatever module you want. There's no specifications around that. So,
thank you.
Just a tiny clarification question.
Yeah.
Okay, in a world where you just have PBS, you just commit to one module. Let's imagine new modules come to market, like some of the really cool examples you provided. if you opt into multiple, can you opt into multiple conflicting, or do you need to only opt into one? I wasn't exactly sure about it.
It's going to be, some of these are going to be very difficult, particularly around like block construction. Is like the PBS and, for instance, pre-comps, they're probably tightly coupled, or like block space features or top of block auctions, they're all going to be tightly coupled. So it either needs to be like one module that encapsulates all that, or some actor that's aggregating that and becoming like the shiner of it. But yeah, that's one dynamic to play out. Now, the way we're thinking about this within Commit Boost is we're actually giving proposers tools that if they want to create logic to alleviate that risk, they can. Commit Boost isn't shipping that logic for them, but like they could open source that and other validators could use that. So for instance, on the Commit Boost software, you could say, hey, if I'm running plain vanilla PBS, don't opt into pre-conf modules, just run that one. So it's just another safety feature we'll think about. But you're 100% right. There's still design space or thinking around that has to take place.
Gotcha. Cool.
Uh-oh. Got him to laugh. I'm good.
So if we trust like single proposer for the pre-confirmations, like how do we check this proposal, whether it's does his job or not?
Yeah, this is sort of outside Commit Boost. This is like the enforcement mechanism, or like verifying that a commitment was actually, that the people downstream actually fulfilled the commitment. It's outside the scope of Commit Boost, but how people are thinking about it is things like proofs. I think is one of the pre-comp schemes is the builder actually provides a proof that the pre-comp was included, and then like the relay will check the proof, and it'll be passed along to the validator. There's those ideas. Whole host of others, but it's not specific to anyone. It could be an eigenlayer or a symbiotic eigenlayer APS. I don't know what symbiotic has yet for that thing, but it could be any of those mechanisms. But this is just on the proposer side and how it provides the signature to register for the commitment, and then subsequently from there, open design space, anyone can build whatever they want.
All right, cool. I think we're gonna cut it there to stay on schedule. Thank you so much, Drew.
Thank you.